Okay. Good morning, everyone. We're gonna start off by showing off a little bit of this network up here. Same as yesterday. It's Altheapalooza and Althea Home. Feel free to log in and follow along. And if anything breaks, I will blame one of you changing things. So it gives me a convenient excuse. So yeah, we're going to get started with the dashboard here. Like most router dashboards, it's just sitting on a local IP address, the gateway IP. One of the big responsibilities of, well, you could say the purpose of an Althea router is to translate the whole encrypted mesh system into something that normal devices understand. So a normal default route. The router's job is to take packets from your computer, where your computer hands them off to the router. It encrypts them, figures out which device to send them to, forwards it off, and generally is an interface into the network so that normal devices don't really have to understand that they're paying for bandwidth or exactly how that's done at all. Here, we're actually looking at this leftmost router. And this one is actually hooked up to the event Wi-Fi and is acting as a gateway. So it has an internet connection coming in. It's then providing that connectivity to this big Linksys router over here over what we call a mesh port. So here, let me head over to the appropriate screen. Here you can see our Wi-Fi and like the port selection stuff. So as you can see, we have 3 ports and they're all assigned differently. Each one would normally be labeled something, but I had to screw with this thing to get it to hook up to the event Wi-Fi, so it's blank. But you can switch these ports to doing any one of 3 things. They can mesh with other devices via WAN connection that can go out to the outside world, or they can be a LAN connection and translate connectivity for your normal wired computer. So this is all switchable and configurable, although we have a default pattern that's like the highlighted port is the WAN port, since most routers have a colored port, and that's the WAN port by default. LAN is the opposite side. Then all the middle are mesh ports. Now, all a mesh port really is just a port that the mesh software is listening on, and that's why we configure our antennas in bridge mode. Because then they pretend to be cables. And this means that we completely do not care about what model of antenna you are using, as long as it provides a bridge mode. So we kind of care about the routers because they're the brains of the thing. So we need to be able to program them. But you can configure any antenna you can buy into bridge mode and use it for Althea, no problem, because it just treats all antennas like wires. So if you can find an antenna that interprets smoke signals, be my guest. Yeah, so if we head over, forgot to really address the neighbor screen. So as you can see, we're this router right now, remember? So we can see that we have connectivity to the Linksys router. We can see what it's charging us, but we're not using that because obviously we'd be buying internet from ourselves through the links. It doesn't make sense topologically. So yeah, let's go ahead and head over to network settings real quick. So here are the exit servers. So this is actually something interesting that is ready now. There's like LibreMesh, there's BMX. There are several other mesh firmwares for routers that work pretty similarly. Althea is the only one that comes with traffic encryption as a mandatory and natively integrated feature. So think of the exit servers as a VPN server combined with a bit of a speed test server, because its job is to make sure that what you saw on the neighbor screen, like it was advertising a quality and a price, you and the exit server can talk and say, I sent you 10 packets. Did you get 10 packets in this amount of time? And the exit server can be like, nah, I didn't. So the quality is not what's being advertised. So this is how you make sure that the people in between you and the outside world aren't lying about what they're selling. And you need a cooperating participant on the other end. So the exit is not only the traffic proxy, it's also that cooperating participant. So yeah, as you can see, we have a few of them. You can register for them. US West takes your email because it actually has Netflix, so we need to make sure that you're actually from America before we let you on it. But you can have exits that just let anyone on. It's up to you. They're not that hard to set up. If you feel like setting up your own, there's a quick little script. If you can spin up a VM on AWS, you can have an exit in 10 minutes. Pretty soon, we're going to have a box where you can add your own exits to this list more easily. The API is already there if you feel like doing it. So next, we have our subnet DAO, and we haven't really addressed this too much. I feel like we touched on it some yesterday. But essentially, the subnet DAO is for the parts of being an internet service provider that don't make sense to bill per usage. So, obviously, you can bill per traffic per byte, but service phone calls are not really proportional to the amount of traffic you use. Perhaps somebody uses very little bandwidth, but has problems with their router or needs technical support frequently. So the subnet DAO sort of decouples bandwidth sales from the sort of hands-on, going to people's homes and helping people out part of the ISP industry. And this is sort of the interface for hooking up a new router to a subnet DAO, which is sort of an interesting challenge because DAOs specifically have like an IP range. Everybody's on them. They're a little bit insulated to prevent hostile actors. So this helps solve the sort of Sybil attack problem, is that somebody has to get an IP address and pay a small fee for it, like $1. Obviously you can't have a billion fake routers if you have to pay $1 per fake router. And it helps to manage IPs because subnetting, for all it may be not the most positively discussed thing in the sort of mesh community, subnets are a very efficient way to handle many devices and separate networks and know where traffic should go. So to get that, but obviously if you don't have an IP, you can't talk with somebody else that has an IP to get an IP. So we use QR codes as a cool little side channel. So the subnet DAO manager or operator would have an Althea app on their phone, and then they could scan the QR code for the router, and then the router could scan the QR code from their phone, and we successfully complete the exchange. I don't think this is the right QR code, so I'm not going to make sure it scans it and then see what happens then, because it's a quick.
We may demo this later.
Yeah.
We do have
Oh yeah, we have a section for this, right? Okay, so I'll go ahead and move on. So over here, you have the payment screen. And so as you can see, we have a couple things going on. We have the price you charge in Ether per gigabyte. And right now, that's static because automatic pricing is actually something of a difficult problem. Who knew? But yeah, so it's fairly easy to say the price should go up when your router is fully saturated. Like when it's computationally saturated, it can't move any more traffic. You should increase your price to forward traffic. That's easy. But the base price is sort of difficult to determine because that's based on environmental factors. What were your costs? How do you make sure you're going to recover your costs? So right now, it's just hard-coded in Ether per, well, not hard-coded, but you set it yourself in Ether per gig. Now below here, we have the price-quality trade-off. And if you have two routes and one of them costs 10% more, but has a 15% better route quality, do you want it versus the one that costs 10% less, but has 15% less route quality? And this is decided by where you put this slider. So if you put it all the way to prefer low price, you're going to take always the cheapest route, even if it's very poor. If you put it all the way up to prefer high quality, you're going to completely ignore price, which may not be wise. So either extreme isn't really the best idea. But for most people, they probably want to dial in something in the middle, especially depending on the network conditions and what their nearby area is really like. And then over here, we have when funds get low. So Althea routers are prepaid. You deposit Ether or whatever stablecoin into the device, and it's going to open a payment channel with the adjacent device, which is metaphorically like putting money on the table and then it can easily move a little bit of that over to the next device at a time. So every couple of seconds, it'll send some tiny fraction of a cent to this other device. As you start to run out of money, the router should probably notify you and maybe try and keep you from blasting right on through out of all of your money, so that you have a little time to go and look for, let's say Windows gets confused and decides it needs to download Windows updates for the next 10 hours. And every time, so for those of you who don't know, when Windows 10 updates fail, they start the download all over again. So you can end up in a loop like that fairly easily. So we're hoping that this helps ameliorate that issue. So now we're actually going to...
Sure. On the pricing, did I understand it? And do I understand it correctly? When you're setting the price, is it the subnet dial as they're signing up the nodes to the network? Do they set the price, or the person who owns the node that sets the price?
Yeah, so there's two. So the question was, how do the subnet DAOs influence prices versus what really is the price we're setting here? So the price we're setting here is our price for passing bandwidth, whereas the subnet DAO is a fee for membership. And these are two different things, because let's say, for example, that I have a tall building and I build a tower on top of my tall building, but I'm not going to go out to people's houses and help them out. You know, it's just, hey, connect to my tower. It's a passive income generator. And that is going to be this price that you select. It's going to be bandwidth payments, because you get paid for the utility you provide the network, which is the bandwidth going through your tower. Whereas subnet DAOs generate their fees from their members, whom they are helping out and otherwise providing services for. So they're different sort of categories of expense, and two separate people who set separate prices.
I have a question, Justin.
Sure.
Is there now, or might there be, surge pricing?
Okay, so the question was about surge pricing. And yeah, so the thought is that, so surge pricing implies that someone is controlling and increasing prices by some definition of when there's a surge. That's sort of right and sort of wrong, in that there can be a surge in that nodes start to get overloaded. And like I was talking about earlier, that is the easiest time for us to know that we need to increase prices, because an overloaded node is going to begin to drop packets. It's going to not provide a good service. It needs to convince people to leave. And if it sends out a price, so if it increases the price, traffic will actually end up flowing around it. Other routes will become better more quickly, and then they will be used. So this isn't exactly surge pricing in like the Uber or the Lyft sense, where there are certain times where things cost more because they're so like when Uber decides it's surge pricing, everyone's prices go up. It's not really a system where individuals are. Okay, so let's back up and try and explain this compared to surge pricing. So let's say that we have Uber's surge pricing model. Uber's surge pricing model is that it's busy, all prices increase, because they want to get more drivers on the road. That's not our situation, because more routers are not going to show up one night when everybody decides to stream videos. So they take a bit longer to set up than that. So we're not raising all the prices. The overloaded devices raise prices, and the network reconfigures. So for most people, they may not actually see an increase in price. They may just see a different route.
But that is, sorry, that is, oh, maybe your answer. That is built in now, or is that, like I could set that up? Or
right now, there's no, right now the price is just fixed.
Okay.
Yeah, we would like to have in the future like plugins, basically pricing plugins. Right now, yeah, it is one number, but that's a place that we'd like to have. There's all kinds of strategies. There could be simple strategies. There could be machine learning strategies. You could connect to other routers, form a cartel. There's all kinds of different pricing strategies. We want to let that ecosystem develop.
So just to repeat what Johan said, obviously, if you look at Wall Street, there's a lot of ways you can do pricing. People can spend their lives on this sort of stuff. Our ultimate goal is to handle some of the really simple cases, like router is overloaded. I should probably increase my price until I'm no longer overloaded. But in general, we want to provide an API for pricing plugins and let everybody do whatever they want with them. Because, yeah, it's a big field, and we don't feel like spending a lot of time on it. So yeah, let's move on to the next part of this, where we're going to hook up to this router in the middle here. It's Althea Home, if you feel like logging on yourself.
Let me.
Oh, yeah.
clarify.
Sure, go ahead.
It's not surge pricing, but it is surge pricing for a different effect.
Yeah. I just wanted to be clear that our surge pricing isn't the same as all prices are increased at
No,
once.
that's fine. So, but in a case where, because the router is pricing higher, so it prices itself out of the market and the data go elsewhere. Now, in a situation where, if you have a situation where that's the only path, the router would then just increase the price and whoever owns the equipment just.
Yeah. So Kenrick brings up a good question. It's how do you deal with, so in some cases, like in this case right now, it's obviously not a very big network. If the gateway over here were to increase the price, this router would be sort of at its mercy. And as a sort of game theory solution to that, we have a hard stop on pricing selection. So there's a price which we're probably going to set to about the price of either 4G data or satellite internet, depending on sort of the region. It's kind of an arbitrary decision. But at that point, the router will simply refuse. It'll cut off the internet before it pays for it. And the idea is that now no seller will ever price their internet above, okay. So the point is that the price for internet on Earth can never be bigger than the price for satellite internet, because you can get that anywhere. So it's literally the cap on the market. And if no router will accept a price higher than that, that sort of extortionate pricing becomes impossible. So no pricing algorithm will go there, because all of the routers will simply quit. They'll walk out. They'll say, nope, we won't take that deal. So it helps sort of provide a disincentive to do crazy pricing, but that's about the most we can do.
Why is that the most you can do? Is there a possibility of writing a condition where it says if you don't have more than 2 or 3, whatever, n options, it doesn't automatically start running the price up? Because there's a lot of distance between, normal and satellite pricing. I mean,
So the question was, can we make the pricing algorithm not do strange things when it's not a very dense network? So not increase prices and do stuff like that. Sure, you can add more and more heuristics or like small little decision choices. And that's not exceptionally hard. And as the controllers of the software, since we write it and distribute it right now, we can definitely do that. And obviously, we're not going to have it be too aggressive with automatic price increases out of the box. But we like to think of these as independently operated devices, because they are. Somebody can install Althea and do whatever they want with it. So ultimately, I prefer to think of it as if the person who's doing extortionate pricing is not running Althea with the settings we distribute it with. They have modified it to do what they want, and that means extortionate pricing. So we can't make their router do stuff, is sort of the fundamental question here. There's more than one device. We can make sure that the defaults are never going to be insane. And in fact, the vast majority of the people probably will use defaults. So it's definitely a much better solution than the worst case scenario we like to talk about. But we like to think about the worst case scenario, make sure we've worked it out.
I think the goal probably would be not so much to get a whole bunch of money, but that you might be able to influence behavior by encouraging someone, because of if pricing goes up, maybe you should go download your Netflix movie offline in the middle of the night rather than streaming it later in the evening. I think having a little bit of price increase maybe helps to encourage that behavior, which is probably good for everybody.
So what Graham was saying is that pricing obviously actually does help make better use of a scarce resource. And bandwidth is really only a scarce resource for a few hours a day, peak bandwidth usage. Other than that, everybody is going to be pricing to recover costs, because nobody's going to be fully saturated 24/7. That's just not a thing that happens in normal networks. Yeah.
So help me understand, you're basing your pricing model on satellite internet?
So,
And let me tell you why I'm asking. Because if I had a choice between Frontier, what sucks right now, and a satellite pricing, I'd go with Frontier. And the only reason is because I can't afford satellite pricing. And I can't afford how much they're going to charge me if I happen to go over my usage, right? So that's basing the model on satellite pricing.
no. So, so my statement is, so first of all, the question was, why involve satellite pricing at all? Why are you bringing in these seemingly random things? And the correct answer to that is that we want to set a hard cap, but it's difficult to, so obviously we can just add a hard cap to the payments page, and that's probably going to happen eventually, and let the user change it. But if we want to ship a hard cap that's going to work anywhere in the world, how do we know that our hard cap isn't below what a reasonable market rate for internet is? Like, let's say somebody had an Althea network in like Antarctica, and bandwidth will always be more expensive than 4G. So it would just cause, so like you'd plug it all in, and it would all turn off right away, because like, nope, that's not allowed.
Yeah, I just wanted to add that the basic thing at play here is that if you charge too much, that people are going to use the service. That's bad for Althea. It's bad for subnet DAO if people switch to something else. And it's bad for Althea as a whole, of course. So we're going to ship defaults, but at the end of the day, that's icing on the cake on top of the pricing model, where basically people say, I value speed this much, and this is the top rate I'm going to pay. So if you have an intermediary node and all of the nodes you're serving have a top rate they're going to pay, and you increase the price, they're just all going to go offline, and then people will switch back to Frontier. But it's kind of a stalemate. It's a negotiation in a way.
It's almost like the price somehow affects the health of the network,
Yes, it
the
does.
overall network.
Yeah.
And like if we're looking at, people that have high interest, they want to set up nodes and stuff like that. And just to make sure, is there a way Althea can probably come up with a pricing model for that specific place to say, okay, if you want to keep your network this healthy, we recommend you to price between, these ranges, right?
Yeah.
Which would be really good information for a first timer, so that they keep within the healthy parameters of the network also.
Yeah. So just to sort of repeat the last two statements, what we're dealing with here is that obviously if the pricing is too high, people are just not going to use Althea, and that's unhealthy for an Althea network, and we should provide guidance on pricing. But that's exactly what we're doing by default. This router charges 10 cents per gig right now. That's effectively cheaper than what most Americans pay. The average American pays 20-ish because they don't use their whole data cap. If you use the whole data cap on the average American connection, it comes out to like 7 or 8. So it's about right. And if everyone used the default settings, then networks would always be healthy, pricing would always be good. We're going to provide that guidance out of the box. When you go to your pricing screen, the settings are going to be sane. It's going to give you a warning if you start doing crazy things. But at the same time, it's going to try and make sure that you that you can recoup your costs. But we also have to think of the possibility of mean or otherwise people who aren't being nice. So I started by talking about the people who aren't being nice, because that's sort of traditional in the distributed software community. That's where you start, because you start with the assumption that somebody's going to try and do mean things, and how do you stop them from doing that? In general, it's funny because none of our current networks have problems with pricing, because everybody's just using the defaults. So it's not, it's certainly not a problem we've encountered yet, but it's a problem we think about a lot.
So,
Yeah.
so two things. One, food for thought. So the scenario that pops into my head is that, again, going back to this idea of the router start automatically raising the price when you don't have options available. That seems as though it comes at exactly at the vulnerable point when you're actually trying to build a network, right? So what happens, the few people that you get on the network if there was only one intermediate, it raised the price and then they jump off, and that you kind of run into,
Yeah.
you keep bumping your own head.
Yeah. So he's saying that you don't want to immediately discourage people, and once again, that's part of designing the default settings. Obviously, if somebody's going to change how their Althea router prices, they're responsible for what they end up doing to people downstream and perhaps causing trouble. But out of the box, it's going to be very conservative about that sort of thing. And so I'm talking about raising prices when nodes are saturated. But in the case, so like let's say this router can do 400 megabits. Let's say it's got 400 megabits from 4 or 5 different clients. It can't go any faster. So all of these clients are losing data. They're losing packets. Like they're trying to get data through. Their connections are not as good. So it's going to start increasing prices, but these people are already having their connection throttled some. So they're not spending as much because no more traffic can travel. You know, it's out of room. But we're talking about the sort of edge cases of the network and like what to do when things go wrong. For the most part, devices spend almost none of their time saturated. Pretty much on the mornings and evenings on weekends, when everybody's like trying to stream video at once, is the only real time you see that. Well, sometimes during weekday evenings, but it's not quite as bad as, not quite as much as on the weekends.
But that's a mature environment, isn't it?
Yeah, it's a mature environment. In any of our existing networks, I don't think anything is significantly saturated at any level of regularity. You mostly run into like antennas being improperly aimed, and they're the bottlenecks, not like routers being fully saturated. So this is all really interesting from the subject of like design, because how do you design an automatic distributed pricing system for a good that expires in terms of seconds? You know, like people have done pricing for goods that expire, like fruits. And you know, obviously they move them around and they try and make as much money as possible. But the thing to realize here is that we're pricing packets, and packets have timeouts in perhaps 60 seconds on the highest, but they really need to be delivered in less than half a second. So you have a good that expires in about 100 milliseconds, and you need to deliver it to everyone who has asked for it. So as far as pricing markets, this is kind of unique, and it's a cool problem to work on. And we're still taking feedback from people and trying to adjust things.
Yeah, right now, you know, we have a preset price that each router is charging. So if each router is charging 5 cents, you'd be about 20 cents per gigabyte after 4 hops, which is probably as far as most networks are going to go. And there's also a top price. We don't have that implemented yet, but that might also maybe put that at 20 cents. In that case, that's a very simplistic pricing model, and there's a huge world of options out there for different pricing models, which we aren't attempting to implement right now.
And which, my last comment, and is more kind of a challenge to the philosophy of democracy when it comes to everyone gets to choose whatever price they want to put there. I mean, to your point that some people can spend their whole life, you know, trying to, you know, just figuring out pricing strategies. So the idea of allowing people to change, to determine what is the best price just willy-nilly, because that's how most people are going to do it. They're just going to say, oh, you know what, I just want to raise my price. Because people aren't rational. They're not going to say, oh, it's going to affect the network and let me turn it down or something. They're just going to, you can bet that most people, you know, if you give them something, they're not going to, you know. So it seems as though it's asking for trouble.
Well, so the statement is that it's sort of asking for trouble. And my sort of counterpoint is that somebody who's just going to go to the pricing page and drag the price to 5,000 ether per byte or something equally absurd is probably not going to modify their Althea software. And when it tells them, no, that's a bad idea, don't do that, they're either going to have to go in, reprogram their router, and do it themselves, which we support and allow, and we have nice guides for how to do it if you feel like it. But most of the people who are going to do something like that without any thought are probably not going to go through those steps. So it's sort of like how moving cigarettes away from the checkout counter and behind the counter dramatically reduces the purchase rate. People do things that are easy first and foremost. So by providing sane defaults and methods that make hostile pricing hard to achieve without knowing what you're doing, we can reduce the vast majority of people who have no idea what they're doing and are just dragging prices over to the extreme. At the end of the day, there's only so much you can protect people from themselves, and there's only so much you can protect people from other people. And society works because most people are pretty okay. Yeah, back first and then forward.
I also kind of think the subnet DAO kind of adds to that, that ability to kind of self-regulate, because if you are in a community where, somebody is trying to overly increase, then hopefully you can form up some sort of union to create a subnet DAO that will circumvent that negative aspect. I mean, it's still rough, and we're kind of talking about something that we don't have a whole lot of data points on, right? I mean,
But what we
in
do
two
have
different
data
environments.
points on is
What?
that, I said what we do have data points on is that people have just shown themselves to be rather irrational,
Yeah.
right? That's quite clear. I mean, that's no surprise, right? It's some things that look very obvious,
Yeah.
people, you scratch your
So-
head when that
People are irrational, but but for the most part, people who are going out of their way to do something get more rational the more effort they put into it and the more talent is required. So there's only so much we can do in a fundamentally distributed system. And he's next.
I think he answered my question.
Yeah. I've been wanting to avoid bringing up. Josh talked about how the subnet DAOs could, in theory, enforce codes of conduct. I didn't want to get into multiple layers of game theory at once here, because we have like network governance and then pricing systems and suggested pricing. So trying to do that off the cuff is not something I felt like keeping up with. Yeah. Well, this is a really interesting subject. Obviously, people care about it because pricing is it's interesting. It's not really something that people have done before. Try and price bandwidth this way, this granularly. Yeah.
I think the bottom line of the pricing is we don't have the answer. We're not trying to solve the answer right now and build castles in the sky. We're going to put it out there and see what problems happen and deal with it.
Hey, Jehan, I was promised a castle in the sky.
You get it.
Okay, I'm just making sure.
How much more of your presentation do you have?
Well, what I was going to do next is that I was going to take, so we have a wireless antenna here that's going to a third node over there, and I was just going to go ahead and plug it in, and we can see somebody appear downstream in a couple of seconds. So let's keep answering questions. Yeah?
I just wanted to also point out that, there is some autonomous nature of it. However, a lot of this is somewhat collaborative because of the sublet DAO. Most people aren't going to figure out that they can become an intermediary without some community involvement. And my experience has been that people actually are fairly altruistic, and especially when it comes to community resilience. And being part of the, certainly they want to be able to be compensated for the resources that they're contributing, but also being part of a collaborative project at the same time. I think that counterbalances the sort of pure greed of numbers that we're talking about here.
Yeah. So what Deborah was saying is that our experiences, at least in Kletsk and I, is it's actually kind of funny, because if you tell people hey, you can make maybe $20 a month if you connect their neighbor, they're not too motivated by that amount of money. If you tell them but if you tell them your neighbor needs internet and their current internet is bad, suddenly they really want to be a good neighbor. As long as they're assured that they're not going to get ripped off, there's automatic protections that keep them from really ending up on the bad side of the steel. People are super happy to help out their neighbor. Strangely enough, they don't always trust their neighbor to help them out. So people are pretty much universally generous, but not necessarily universally trusting of others' generosity. At least that's our sort of experienced so far, and I thought that was a funny result.
So I just wanted to clarify, like, the actual price of bandwidth across any given link. So that's always going to be set by the nearest upstream peer. Is that right? It's not going to be like an additive thing.
No, no, it is additive. So how it works is that payment in Althea is pay per forward, and it's not pay per internet connection. It's not pay per like upload download. It's pay per forward. So all payment is done in one direction. So like upload payments and download payments are separate. And what this does is that it means that you cannot have DOS attacks on the network. Nobody on the Althea network can spam traffic to everyone else and like generally annoy them without paying for it. And at that point you're like, yes, please pay me to send me junk traffic, and you can call it not a problem. So what will happen is that this router will charge, let's say, 10 cents since it's a gateway. This router is going to charge another 5 cents, and so the router over there is going to see 15. What's actually interesting, and I think this point bears focusing on for a bit, is that we don't actually stop. So the gateway, when it wants to send traffic back to the edge here, it's going to hand 15 cents to. So that's not quite right. So let's do this from the other direction because it works better that way. The router over on the other side of the room is going to hand the lump sum. It's going to hand 15 cents per gig to the Linksys router that will take its cut and then pass it on to the GL. And the reason this works is because of the payment channel technology that allows us to do payments once every 5 seconds, or really as fast as we want, but once every 5 seconds is fine. This means that even if nodes are transferring like a gigabit per second, you're at most going to get a dime between updates, or it's really closer to a nickel. So this is actually a cryptocurrency innovation. You need to do this. If, like, let's say you didn't want to use cryptocurrency at all, you're like, why can't, why do you need cryptocurrency mesh networks? Clearly you could use credit cards or bank transactions. There's a whole financial system. Let's say we wanted to hook into that. We still need payment channels. We still need the concept from cryptocurrency of payment channels to allow frequent local updates like that, because that means that we can talk to the outside world to open a channel and deposit and put some money on the table, so to speak, and then to move money around on the table, we only have to talk to each other, which helps prevent the system from becoming self-referential. Because if you need to talk to the outside world to send data to the outside world all the time, you can end up in a loop that's not resolvable. So yeah, now we can see that we have the node north of us. You'll notice it has a strong connection to the exit, and a node south of us, which has a bit worse of a connection, but this will improve as Babel as Babel stays connected longer and gets a better idea of what the connection is really like. Babel doesn't like to pick connections very quickly because it's worried about switching too fast. So the situation I always like to talk about is that let's imagine you have an overloaded node, and everybody decides to switch to the not overloaded node at once really quickly, then that node's going to be overloaded and you're just going to go back and forth. It's called route flapping, which is why Babel takes a little while to get up to the strong level of connection up there before it really trusts the new peer so that it doesn't flap around all the time.
Does that not have anything to do with signal strength at all?
No, that doesn't have anything to do with signal strength at all. It's just trying to smooth it. So it actually takes the signal strength and starts it and artificially decreases the route quality for a while, and then it curves down. So it's so there's some smoothing so that it doesn't suddenly drop as it comes in, and it just sort of curves down gently. And that keeps nodes entering or leaving the network from causing the whole network to be like, hey, there's a new route, everybody change. And then like, oh, wait, that route wasn't quite as good as we thought it was, and now everybody has to change back. I
was just wondering, the overall, the link, basically, the stats for the link, if that had anything to do with it.
Yeah.
I was curious, like in a scenario where you just have, I guess, one route and I guess multiple requests and different data types, like someone streaming, someone sending an email. Is there any type of,
Yeah, traffic prioritization. So the question is, let's say your neighbor really likes to torrent, and they're downloading an enormous amount of Linux ISOs. And as they do that, you are trying to hold a voice chat. So very, very small amount of data, a few kilobits. What do the routers decide to do? And we actually use an algorithm called flow queue co-deletion, or FQCODL. And you can find this on bufferbloat.net. And what this does is that it prioritizes traffic into buckets based on the stream. So every connection a router is passing goes into a bucket. And then your router goes to empty all of the buckets. So like it's going down the row of buckets and it's emptying the bucket. And it tries to empty all of the buckets if it can. But if the average amount of time that traffic waits in this bucket queue is greater than 5 milliseconds, it starts looking for the biggest bucket, the person who's hogging the connection, and it puts them last. So then it'll empty all of the less full, all the smaller connections first. And what this means is that your voice chat will go in front of somebody's web page, will go in front of somebody's video streaming, will go in front of somebody's big download. And the nice thing about this is that it encourages maximum usage of the connection. There are a lot of fancy graphs that are kind of hard to read but really cool that show that FQCODL results in higher and better connection utilization. And most people don't notice it's being run on them. Because, for example, Netflix will buffer 5 minutes of video because it knows it's a big bandwidth hog, and it doesn't want to not be a good neighbor to all the other traffic. So it can be bumped down and wait a few seconds while somebody's web page goes through, and nobody will ever notice. Well, they will notice if their web page didn't go through first. Then it's very slow. Yeah.
I just want to come back to Sean's question about the link quality. That link to me and link to exit, that is actually about the quality of the radio link. So right now it may be low because it's taking a long time to adjust. Maybe the radios
I was
aren't
thinking,
even.
yeah, that's why I mentioned, because this one doesn't look like it's really pointed right at that
Well,
one.
maybe turn the power down on these.
It might be it might be something like that.
Me is the link
Yeah, this is me right now.
So the
Because I switched from this one to this one as part of the demo to show somebody in between.
so that's the GL is the FDB and FDA is the device.
Justin, let's take a few more questions and then try to wrap up.
Yeah. So, I think that's about everything. If you're interested, I can show you how to poke around SSH and look at some of the deeper internals, but I'll save that for a different time. Does anybody have any other questions? Cool. What's next on our agenda? Or do we have a couple more minutes?
No, it's
Graham's turn?
Graham's turn.
Okay, cool.
Yep.